Assalamu alaikum, this is Dr. Osman Sadiq Paracha, and today we would be having our lecture number 26 of the subject Applied Quantitative Analysis and Practices. Previously in our lecture we were discussing about some important concepts which were related to confidence interval, and what's the concept behind that, why is it important, and why we need to calculate the confidence interval specifically for regression purposes. And normally we then had discussion on various examples of confidence interval, and what are the formula and how we have to calculate the confidence interval in case we are given specific population parameters, and in those cases when we are not given any population parameters in this case. So in this case, after going through that, we just had a discussion on the T-test, which is necessary for testing of correlation coefficient, and then again what's the application of this T-test there. Then we had a brief discussion on the application and how basically a T-test value is important, and then again significance value of the correlation coefficient for this T-test is also important, because after all this whole debate basically is about a sample. So when we are talking about sample, we have to take out the probability of whether any kind of statistic would be giving us the same result if some other sample is taken out from the same population. So again, for hypothesis testing, we have to basically go through this procedure of T-test or even Z-test, depending upon the nature of the coefficient which we are trying to evaluate. So we just had a brief discussion on that. Then we discussed about various discrepancies in regression, what are the pitfalls, and what are the things we should avoid in regression. And then again, when we are discussing about the discrepancies, then how to avoid them, what are the strategies to avoid such kind of pitfalls. So we just had a brief discussion on that, and then we started on a case study in which we had to find out a certain relationship through regression. So just going through this brief outline, and let's have a look at briefly how we were going through. And again, this was a conceptual diagram in which we know that we don't know about the population parameters, and based on that you can see that once we are taking a random sample, then we are basically talking about how much confident we are that our population mean would lie in between certain range. So in order to be confident, and level of confidence again depends upon the way you are conducting this estimation process. So this was basically the concept which we discussed in confidence interval case, and which was important, though we have gone through many formulas, but the crux of the whole thing matters a lot more than the formula. So that's why this was the main concept. And then this was the formula basically which we discussed for calculating these confidence interval, which you can see here in this box in which point we are taking a point estimate plus minus its critical value and multiplied by standard error. So here again critical value is calculated by through this table, which is based on this sampling distribution of the point estimate and the desired confidence level. Likewise, we have already discussed about the standard error in this case. So basically the whole point is that the formula basically for confidence interval will be dependent upon whether you know the population parameters or not, but the concept which we have discussed remains the same. And this is just the background of what's the process which goes on behind. And when we are taking a 95% confidence interval, in that case then how the whole normal distribution is drawn, and in that case you can see that it's the same process, and we are just considering the same non-rejection region, rejection region as we have discussed before, and the level of significance is indicated from these two values which you can see at both ends. It's a typical conventional diagram which is used to basically calculate the critical value. Again here the commonly used confidence intervals which we have, and what is their interpretation in the form 1 minus alpha, and then what would be the z value in this case. So based on that you can very much see that here these are the typical z values which are followed in nearly any kind of calculation. Normally we use 95% confidence intervals specifically in terms of business research or business studies analysis. Also it is though kind of rare that 99% confidence interval is used. Reason being so that there's not that much accuracy demanded for business applications. So though 99% or more than 99% confidence interval is used and is more important in studies which are very critical in nature, like medical sciences and natural sciences, where the nature of the finding is very much critically important. So in that case, therefore, we opt for a very much higher confidence level as compared to business studies. So that's why we have got this kind of predetermined chart which is made, and the values are known, so that it's easy to depute these values in the formula and calculate the required result. So then we just had a diagrammatic view of how would this confidence interval, these things look like, and how we are going to draw them. So this is just a typical normal distribution diagram which you can see here, and likewise we have got an issue of these are the confidence intervals which differ in different samples, and then we have to calculate if any interval is out of range, and sometimes it does. So in this example we have just highlighted one. So the main thing here basically which needs to be considered is that yes, we can calculate different confidence intervals, and sometimes our values can come within the range. Normally mostly most of these confidence interval values come within this range. So rarely there are values in which we have got an out of range phenomena, which you can see here. So well, likewise then we went through a typical example in which we had a sample of certain circuits, and we were given certain mean and standard deviation of the whole population here, and we had to determine the 95% confidence interval in this case. Now we just deputed the formula, and we just showed how to calculate the values and how to calculate the lower limit and upper limit of these confidence intervals in this case. So this is the typical example which is used in this basic lecture, and we basically went on with it to explain the calculation of this concept. Then we had a discussion on the interpretation, as you can see, and then how to go ahead with values here. Then we had a brief discussion on the t-test for correlation coefficient, and as you can see, it's the same thing as how we developed the hypothesis, the null hypothesis and alternative hypothesis, but the means to test these hypotheses is based on t statistics here. Again, in terms of correlation, the formula is kind of different, which you can see here. And likewise, you can see that we have got interference of degree of freedom as well here. So this is a standard procedure to basically test any kind of hypothesis here. And again, in order to test these hypotheses, not only we do have to calculate the test statistic, but also the level of significance. So basically, then we went on with the pitfalls which we have to go through in regression analysis. Normally, there's very less awareness in terms of the methodologies involved in regression analysis. That's why only least square method is mostly used, but again there are other methods as well, and in case of any complication in present least square regression method, then we can opt for other methods also. Then how to evaluate the assumptions, this is a big question mark. Again, very less awareness is there, and again then we have got very little know-how of how to go for alternative methods if the assumptions are not met for any specific method which we are trying to imply. Then the most important thing is the usage of regression model or technique randomly, because this must be kept in mind that all these tests basically rely on the theoretical perspective and what is the theory saying, and basically these statistical tools are just the means to test that specific logic or argument which has been well argued upon, well defended upon in the literature among the scholars. So basically just applying a randomly regression model in this situation is very much deniable here, and it should not be followed here. So again then the another big anomaly here is the extrapolation and outside the relevant range, and we have discussed before that we can deploy this interpolation case specifically, but again we have to take care of this fact that the value which we try to find out should be within those lower and upper limits of this whole data set. So going beyond that basically is the critical error then in regression analysis, which should be avoided by the user, and going ahead of that would make it more like a future prediction, which basically regression analysis does not do. So these pitfalls are there. Then we have to discuss about the strategies which can be followed to avoid such kind of issues. So first thing, as we have discussed before, is related to scatter plotting. Now in case of scatter plotting with reference to the two variables which we want to observe here, basically this is used to have an idea about the nature of relationship which may be existing between the two variables. So That's the initial strategy, so that we can have a brief idea of what kind of relationship we are looking upon. And likewise, then the suitable regression analysis can be chosen based on that. Then the other important strategy is related to the residual analysis, because residuals, as we have discussed before, are related to the errors in the regression readings, and their analysis basically do prove a number of things which we require. So in order to check the assumptions, we do take the help of this residual analysis. And first thing which we had discussed before was related to homoscedasticity, and basically the residuals are plotted and certain kind of pattern is desired so as to ensure that we don't have a situation like homoscedasticity here. Then in order to ensure the normality, then we can use, and we have been using, histograms, stem and leaf display, box plotting on normal probability plot of residuals here. So this is the typical way to avoid this non-normality issue. These are the primary strategies which can be used to avoid any kind of complications which may occur while we are performing tests for assumptions and all the conditions which need to be met for regression analysis. So then we had further issues like we may have violation of assumptions, so it's not always necessary that you or all of your assumptions are justified, satisfied, and if there is violation, then we have to look for alternative methods. We have to look for alternative models in this case. Then if there is no violation in assumption, then we can go ahead with the rest of the process, and that is like that we want to test for the significance of that regression variate which we have just which we have just calculated. Then we have to evaluate the confidence intervals as well and prediction levels as well, and so that there is no issue at the end. And then again, as we have discussed before, that we should avoid future predictions. Once we have gone through all these major strategies which can play an important role, then we went on ahead with our application on SPSS. So having a look at this example, we can claim that number of students who are appearing in exam have an impact on number of students which are passed in exam. So from this basic model, we just want to know whether these two terms are interrelated, then whether number of students who are appearing in exam really cause the number of students to pass. So in other words, the number of students who are passing in exam are dependent upon number of students who are appearing. So here basically we just went through to have an example in SPSS. So going back to SPSS here, we can just have a look at the same example, and you can see here that we have got two primarily points. One is number of students who are appearing, and the second is number of students who have passed. In order to take the analysis, we basically click on Analysis Analyze button, and we click on Regression, we click on Linear. Now here we can choose our dependent variable. Here it depends upon the variable which we want to see. So here basically we can say that number of students who have basically passed is the dependent variable, and independent variable is like number of students who have appeared in exam. So this is just a simple linear regression, and in this case we have got only two basic entities, and we just want to find out the nature of the relationship between these two of them and how we can interpret them. So when we have entered the dependent and independent variable, then we have to state the statistics. And here you can see that one important thing is R-square change, then the third is descriptives, then we have got part and partial correlation, then collinearity diagnostics, and then Durbin-Watson test, which we will discuss about in detail ahead. We click on continue, then we click on plots, and here we would like to know whether one condition specifically is being satisfied or not. And in order to find out these one or two or even three conditions like homoscedasticity and then this linearity and normality, then we can opt for a residual graph in which Z predicted basically is at y-axis and Z residual is basically an x-axis here. So you click on that, then we click on histogram and normal probability plotting, which you would like to know, so that the conditions are being met here. You click on continue. So once we have entered these dependent and independent variables here, you can see that there is another drop down menu, and in which in front of method here. So here it's written as enter. There are some other methods also which we will discuss in detail afterwards, but basically currently we are opting for enter method, and normally in simple linear regression, and this is the only method which is followed, and there is only one independent variable which is used here in simple linear regression. So coming to the statistics, again we are going through nearly all the linear regression statistics as we have discussed before, that we opted for all the R-square change and partial and collinearity diagnostic and Durbin-Watson as well. Then we go to plots. We have discussed already that this in this case we are focusing upon the z-values for predicted and z-values for residual, and we just right now opted for both of these, and we opted for histogram and normal probability plotting here. Then we click on continue, then coming to save. Basically these are the residuals and predicted values which can be saved. What's the logic behind these values and why certain scales should be saved, this would be discussed in detail when we are going through multiple regression phenomena, and we will discuss that in detail over there. So clicking on continue here, we click on options, and here you can see that we have to mention that what would be the probability for F-test, and we can basically identify the level of significance which is to be used for calculating probability of F. Then do you want to include constant in the equation or not? Well, it's better not to disturb this option, and then we are given the option for missing values, like if exclude case list-wise, that if there is any case missing, any value missing in any variable for a specific case, then that whole case will not be considered. Then we have got another one is exclude cases pairwise, in which in this case, though if the values of the relevant variable which is to be used in this analysis, if that value is missing, then we will not commence with that case, and that case will automatically be ignored. However, if other than that specific variable which is in question in that analysis, if some other variable value is missing, then in that case we can say that that case value will not be ignored. That's why we say that this option is exclude cases pairwise. So again, the third option, replace with mean, this is just a treatment that if there is a value missing, and we can replace it with the mean of all the values in that specific variable. But again, this is not wise to commence with such a treatment for missing values, because sometimes this one whole case can mislead the whole results. So that's why we basically try to get all the responses from all the respondents in the questionnaire in order to ensure that there is no question unanswered. So in that case, it gives us an edge that we have all got these valid questionnaires and all the values are valid, so we don't have an issue regarding missing values here. So clicking on continue here, let's click on OK and just have a look at the result, which we were having a look at it before. And you can very much see that the descriptive statistics for past and appear are displayed, and we are also given the n value, or the total number of cases which are valid, and here in this case they are 1081. And then we are also given the relative mean values and standard deviation values of these both variables, just to have an idea of what kind of data we are dealing with. Then we are given the correlation values, which basically give us the idea about these two variables relationship in advance. And here you can see that the value 0.774 does indicate that these two entities are kind of related to each other in positive direction, and these values are also significant. Then we are given detail of variables which are entered and which are removed. Here the variable entered is appeared variable. Then here we are given a model summary in which you can see that the R value is given. Again, gives us the nature of relationship, and R square basically it gives us the proportion of variance which is accounted for in dependent variable. And then we have got adjusted R square. Now here adjusted R square is the value which is calculated by removing any kind of error in original R square value. And there is one discrepancy regarding R square value, that this value can tend to increase if we keep on increasing the number of variables in the main simple linear regression equation. So in order to remove that anomaly, we have got an adjusted R square value which is reported, and such kind of errors are omitted from the original value. Then we have got the standard error of estimate here. Now here we are given also the standard error of estimate, and as we have discussed before, that standard error of estimate basically gives us an idea of the error, and the smaller is the value, the more better it is. So here basically then we are given the value of R square change, which is the same like 0.599, and by R square change we mean that if we were to include multiple independent variables, then in that case we would have measured that via the induction of another variable, what's the difference between the first model and second model, and how basically much change has come in R square. So that is denoted by R square change here. And then we are given the F statistics here, which is stated along with the significance also, which gives us the idea that this model is on overall it is justified. Then we are given a Durbin-Watson test. Basically this test is in order to detect if there is any kind of autocorrelation between independent variables. So these values should lie near to 2. So this is 1.54, so it's kind of acceptable here. Then we have got another case in which we are reported the values for ANOVA, and here you can see that the regression values are reported here. Obviously they are reported through sum of squares, and once they are calculated, then we have calculated the mean square as well. And you can very much see that in regression this mean square is quite high, also significant, and in case of residuals these values are basically very low. So in this case, in any kind of model, if the value of regression is much higher than the value of residuals, then in that case that analysis or regression analysis is considered fit. So based on that, we can say that the significance level gives us a very good idea of how much meaningful these values are. Then coming to the coefficients, then afterwards we are given some additional details regarding coefficients. These are again individual coefficients, and we are given the value of unstandardized coefficient, in which beta basically for constant is given and its standard error is also given here. Then we have got number of students who have appeared. Basically this is our independent variable here. So you can very much see that the unstandardized coefficients are reported. But if we have got multiple independent variables, we would like to have that which coefficient is better than the other. But the main thing is that as these standards are different in every field, so basically you can see that in this case in social sciences basically we have to standardize these coefficients as well, and by standardizing we can then ensure that these independent variables are comparable to each other. So once that is calculated, and you can see it's 0.774, here it must be kept in mind that if we are applying typical simple regression analysis, then in this case it is important that standardized coefficients are created, but in this case, in case of more than one, then we are more reliable on standardized coefficients. Reason being so that only through standardized coefficients we can compare among all the values that which value is better in this case. Then we have performed the Ttest here for the constant and for the student number of students appeared as well. Now here basically the Ttest value, when given, there is also another column here which relates to the significance of T value, and here you can see that the T value is 0.815, but the significance is 0.415. But it doesn't make much of a sense because we are talking about intercept here, and that varies. So then we have got another T value which is reported for the another independent variable, which you can see as 40.14, but it is significant, in fact highly significant. So in this case we can say that yes, to some extent a number of students appeared are basically involved in predicting number of students passed. So here we are also given various types of correlations, but they would remain the same because we are only taking one variable as in the analysis for simple regression. So once we have gone through that, then we have got another important statistic which is reported related to collinearity, so that not too many questions just jumble up having the same meaning. So in order to avoid that, we do test collinearity statistics, and in that you can see that the tolerance and VIF are the main basic indicators for that. In tolerance, you can say it's kind of a measure which basically tells us how much well representative the data is. So in this case, you can see that the tolerance level basically is 1, which is kind of I would say alright. We will discuss more about collinearity statistics in detail. Basically, this is used to detect if the independent variables are correlated with each other. Then the higher the correlation is existing between the independent variables, then it would impact the result of regression for independent and dependent variables. So in order to test that thing, whether these values are like collinearity diagnostics do conform to the guidelines or not, because so that we can avoid these kind of complications which arise if we are saying that the tolerance value or the VIF basically, or the, in other words, the independent variables are highly correlated to each other. So coming to the collinearity diagnostics. So in collinearity diagnostic, you can see that we have got 2 dimensions, and we are given certain eigenvalues against which we are given variance proportions. Now the key to the fact is that for each eigenvalue we should ensure that all the variables load on separate load highly on separate eigenvalues in this case. So here basically constant is not considered, only the number of students appeared are being considered. So we are not very much concerned with this collinearity diagnostics. So it more depends upon the basically nature of the sample and the values obtained. So then we have got residual statistics, and you can see that we are given certain predicted values, residual, standard predictive values, and standardized residuals here. Now these residual statistics basically have different usefulness, and in this case we would discuss this in detail when we are analyzing the multiple regression function. So in this case we are given the residual statistics, and coming to the chart, we are also given the residual analysis in terms of presentation, and here we can see the histogram is portraying that the distribution is kind of normal, so this is acceptable. Then we have got another chart in which we have to basically plot the regression standardized residuals against known data here. So based on that, you can see that the values should lie on the line or near the line, and only then we can basically speculate that okay, fine, this regression analysis is without bias. Then we have got a scatter plot in which you can see a certain pattern emerging. Now here the things are a bit different, because a scatter plot does show that maybe this kind of sample may not be justifying homoscedasticity. So once we have gone through this thing, then this SPSS interpretation becomes very easy. So in regression, basically for simple linear regression, only the simple statistics are used. We are not in need of a very complicated process, so this is the standard procedure to follow all these things. And here you can very much see that the various analyses are conducted simultaneously in SPSS, so it does guide us how to basically interpret them, and how to move ahead with them, and based on that you can see that these values are of major importance. And then let's have a look at another file, another kind of analysis which we can perform on. For example, let's say we just want to know the impact of advertisement on the album sales, basically the CD sales. So in order to do that, we go to data view, we click on analyze, and then we just click on regression, click on linear. So here we can select the album sales, which is the dependent variable in our theoretical perspective, and then we have got certain attractiveness of brand, and we can, or in other words, we can just lie advertising budget. So let's just test this whole model based on advertising budget. So we click on that, and then again we click on statistics, and we click on R-square chain, descriptives, partial correlation, covariance matrix, collinearity diagnostics. Then we click on Durbin-Watson test, and we click on continue. Then we have to look at the plotting, and in this case we require histogram, normal probability plot, and we also would like to know about Z predicted and Z residual. So this is the standard check to basically ensure that the assumptions of all these regression steps are met. So we click on continue, and then again we have got, by saving the option or clicking on save, we are facing the same issue which we will discuss again at the end of this these sessions. So let's click on options. Again, it's the same value which we have basically considered, though you can change the F value and you can use it, but then for that you need to be very expert in your subject area. So once you have gone through that, you can have to decide about the missing value cases, which you can do. So just click on OK, and we can see here that the total valid number of respondents is 200 here. Now here in this case you can see that the correlation between the album sales and advertisement budget is given, and you can see that advertisement budget is its correlation with album scale is 0.578, so that means 58% variance is accounted for by advertising budget. Here we are given the model summary of the second model which we discussed, and in this case you can see that R value is 0.578, R square again is smaller, and our adjusted R square is around about, is having little difference. Then we are given the standard error of the estimate here, and in this case again it's kind of smaller, but F change here is given and it's significant. That means that this model is basically feasible, and in this case we can claim that there is a relationship between advertising budget and album sales. And however, advertising budget is causing the album sales to improve. So Durbin-Watson test here gives us the value of 2.0, showing us that there is no autocorrelation between the variables. Once we have gone through that, then we are going through the same exercise in which we can see that the regression value, which basically is the main value explained, is 433,687, but in case of residuals this value is very small. That means that the relationship is stronger and more points are explained by this regression phenomena. Then we have got the F statistic and its significance as well, which is clear cut. Then we have got the set of values for unstandardized coefficient and standardized coefficient, and normally we can follow the same procedure in which the standardized coefficient is only used when there are one or more than one variables. Here as there are none, so standardized coefficient would be the same as R square. Based on it, then we move ahead with the calculation of t-values in order to know whether these values really are the same when another sample is taken out from the same population. So once we have gone through that, then we can see that the significance of these coefficients is quite high. So likewise, we have got some various types of correlations, the details of which again we will discuss afterwards. And then comes collinearity diagnostics. Then here basically you can see that the correlation between them is positive, and then we are dealing with the collinearity diagnostics as well, in which we are given eigenvalues, and it is necessary that for each eigenvalue only one variable should be loaded on a separate eigenvalue. Now here constant is kind of an exception, so other than that we have to look for every value whether it is in that specific dimension or which is conforming to the eigenvalue, or whether there are one or more than one values which are loading on the same eigenvalue, then that would create a problem for us. So based on that, then we have got residual analysis, and then we are going for the histogram of residuals, so it's kind of normal, so there's nothing to worry about here. Then we have to draw the PV plot. Again, these values are coming on the line away, a bit away from that, but on the line mostly. Then we do the scatter plot basically between the regression standardized residuals, and in this case you can see that there is no specific pattern forming, so this kind of relationship basically is free from homoscedasticity. So basically these are the different models which we discussed in order to have a clear-cut idea of what this whole debate is about. In today's lecture, we basically discussed about various applications of simple linear regression, how to select the data, how to cater it, how to basically click on various options which are available. And also we have to look upon like that what kind of statistics are required in the standard form in simple linear regression, and likewise how to basically assess various options which will be helpful in the SPS application in this case. Then we generated the results for examples basically. And in this case, first example was related to a model in which number of students basically appeared who are having an impact on number of students passed. So in order to test that model, we have to rely on simple linear regression in SPSS, and in that case we just put the values and then we generated the results. And once we generated it, then we discussed about what would model summary box mean, and what are the values interpretation in those various different kind of statistical figures which are reported in SPSS. So once we went through that, then the important part was how to basically check out the assumptions for this simple linear regression. So the regression rules were same for assumptions, and then we counted on the histogram and the normal PV plotting in order to know whether the assumptions are being met or not. And once we went through it, then we took the second example in which we tried to find out the relationship between album sales and the advertising budget, and from there it was quite evident that there is a positive relationship. And then we had a detailed discussion on this basic phenomena, that how to basically go through this various applications, what are the aspects which need to be considered in this specific case. Once we have gone through that, then we have to see whether this kind of application is applicable for other options as well. So based on that, simple linear regression basically is an important phenomena, and its SPSS application gave us a very good advantage of getting to know the various statistics in a more fruitful way and how to basically assess the whole model in this case. So once we have gone through that, we can easily detect the anomalies through the collinearity diagnostics, through residual diagnostics, and we can also use some of the residual analysis when required, but these concepts would be discussed in detail in multiple regression. In addition to our debate about this simple linear regression, I would like to add that multiple linear regression is also part of our course, and unlike simple linear regression, multiple regression involves more than one independent variable, and as we will discuss before, that once we are adding more variables and their impact on dependent variable, then such kind of regression which is run on these type of analysis is termed as multiple regression. Though in multiple regression the model becomes more sophisticated, and though somewhat the assumptions for simple linear regression and multiple regression are mostly the same, but there is some little difference which we will discuss afterwards. Practically speaking, as in real life, the models which we see and the variables which are impacting on different kinds of dependent variable, like organizational performance, like organization productivity, or turnover, or employee satisfaction, or organizational commitment. Basically, this has been identified that simply one variable is not impacting such kind of outputs, whether they are tangible outputs or intangible outputs related to human beings on the organization or the organization in this case. So once we are dealing with number of factors which are impacting our dependent variable, then in that case the model becomes more sophisticated, and therefore this simple technique of simple linear regression is not applicable in that case anymore. So in order to have a real-time picture of how these multiple variables impact on the dependent variable, then we have to deploy more sophisticated technique which is termed as multiple regression. And unlike simple linear regression, we will get to know that there is not one method for multiple regression. There are numerous methods which are involved in this case, and every method basically has got its own prerequisites, its own advantages and disadvantages in this case. So in this case, when we are dealing with multiple regression, when we are applying more than one variable impact, then the important thing is that we do have to see that the correlation among those independent variables does not impact the regression results. So in this case, unlike simple linear regression, due to the presence of more than one independent variable, we have to additionally look into other possibilities as well. For example, we do have to look out for possible high correlation among independent variables, because if this high correlation is significant, then in that case our regression results may be biased in this case. So that makes multiple regression a bit more complicated than simple linear regression. and that's why some additional techniques and methodologies are followed, which would ensure that our multiple regression is robust enough and the findings which are reported are not affected by intercorrelation between these independent variables. So basically the phenomena which we just discussed was a very simple one, and that's why it's always very easy to find out the relationship between only one variable and one dependent variable. But in reality, when we are dealing with more than one variable, and in this case they can lead to 10 variables, 20 variables, or any number you can like. But again, the more the number of independent variables, the more sophisticated would be the multiple regression technique. And again there would be more chances of biasness, and we would have to apply more sophisticated tests in order to ensure that our findings are unbiased. So in this case, in case of multiple regression, the assumptions which we have discussed in terms of simple linear regression, they also get complicated in this case, and this is vital that they should be basically considered in order to ensure that the results which are reported under multiple regression are not conflicted, and there is no conflict of interest there also. So while considering multiple regression, we have to consider some additional assumptions, some additional phenomena, and though there are advantages that we do get to know about the complexity of the model, and the practical application becomes more evident and more clear in this case. So while considering this thing, simple linear regression is limited, and its findings are limited, and its practicability is also limited, and that's the advantage we have in multiple regression, that we do get some additional insight in the complexity of the phenomena in the organization which we are trying to observe. So the more additional dimensions in that model, the more clear picture would be in this case, in which we can clearly see that what are the independent variables which have more impact on dependent variable, and how we can basically alter these independent variables to improve our organizational performance. Just for an instance, this can be one example. So we would be doing this more in detail in this case. Thank you so much. Allah Hafiz.